Hello everyone. We are starting with tutorial 3, question number 1. And in this question, we are supposed to solve the following homogeneous equations with variable coefficients. And these are type of Cauchy's homogeneous linear equation. Now, what is Cauchy's homogeneous linear equation? Let's try to understand it first. So, in Cauchy's homogeneous linear equation, the power of x joining the uh, derivative part, the order of derivative and the power of x is same. So what I mean to say is, if there is x square written over here, then it will be second derivative of y. If there is x written over here, then it will be first derivative of y. And if there is no x, there will be zeroth order of the derivative. Now this is the part of or this is the type of Cauchy's homogeneous linear equation. Now how to solve this? There is a technique for this. We assume the x to be equal to e raised to the power z. From here, if you take log on both the sides, you'll get log of x is equals to z. Now if you differentiate this x part, you are going to get some of the things which we are going to use while solving this homogeneous linear equation. So the result that you are going to get is x times dy by dx. It is equivalent to d of y. Similarly, x square d square y by dx square is equivalent to d minus 1 of y. Since we are only interested in up to second order over here, so I'll be substituting these two values in the given equation to modify the given equation. So my given equation becomes d minus y minus 1 of y minus 2.5 times d of y minus 2 of y is equals to 0. So if I open up the first bracket, I'm going to get d square minus d. Okay, I'll take y common as well. Minus 2.5 times d minus 2 of y is equals to 0. On solving this, you'll get d square minus 3.5 times d minus 2 of y is equals to 0. So from here, I'll obtain my auxiliary equation, and my auxiliary equation becomes m square minus 3.5 times m minus 2 is equals to 0. Now, since there is a decimal point over here, I'll simplify it by multiplying the entire equation by 2 so that I get 2m square minus 7m minus 4 is equals to 0. Now, I need to find out the roots. It's quite simple to find out the roots from by splitting the middle terms. As you can see, the first term is 2, the last term is 4. So multiplication will be 8. And we know that minus 8 plus 1 is equals to minus 7. So I'll split the middle term. I'll get minus 8m plus m minus 4. Now from the first two terms, I can get 2 and m common. So I'll be left with m minus 4. And from the second two terms, I'll get 1 common. So I'll be left with m minus 4. So I get two roots over here, 2m plus 1 and m minus 4 equals to 0, which gives me the value of m in the first case to be equal to m equals to minus 1 by 2, and the second case m equal to 4. If you substitute this equation equal to 0, you'll get m equals to minus 1 by 2, and if you substitute this equation equal to 0, you'll get m equals to 4. Since I got the two roots, I can easily find out or substitute this thing into the equation, which is c1 e raised to m1 x plus c2 e raised to m2x. This thing we have seen earlier in tutorial 2, and this is applicable only for the cases where m1 and m2, the two values of m, they are not equal. So if I substitute the value, I'll get e raised to the power minus 1 by 2 x plus c2 e raised to the power 4x. Now, one thing I would like to change over here. In this case, this won't be x, rather it will be z, because the z is what we have calculated over here. So this is I calculated. Now, if I substitute the value of z over here, that is log of x, I can certainly get a modified equation which will become e raised to the power minus 1 by 2 log x plus c2 e raised to the power 4 log x. Now, since log into the power of exponential, this term will cancel out the exponential part, and you will get some answer equivalent to, see, this minus 1 by 2. It will go to the power of x, so it will become x raised to the power minus 1 by 2 plus c2. This 4 will go to the power of x, so it will become x raised to 4. So this is going to be your final answer for this type of question. Now let's try to see the next question. Now in this question, it is quite similar to the previous one, except for the fact that some initial boundary conditions are given. So we'll be using these initial boundary conditions at the end. First of all, let's follow the same procedure. So the equation which has been given over here, I'll be substituting x square y double dash as d minus 1 of y and xy dash as d of y in the above equation. So let's try to substitute these values. I'll get d minus 1 of y minus 3 times d of y plus 4y is equals to 0, or d square minus g minus 3d plus 4 of y. See, I've taken the y common out of here, so I'll be left with this. So this will be d square minus 4d plus 4 of y is equals to 0. So now the auxiliary equation I obtain becomes m square minus 4m plus 4 is equals to 0. Now this is the expansion of m minus 2 whole square equals to 0. So from here you'll get the two roots m1 and m2, both of them equal to 2. Now the case for which both of the roots are same, the value of y, it goes like c1 plus c2 times x e raised to the power mx. In this case it will be z, right, as seen earlier. So your equation will become y is equals to c1 plus c2. Z, we know it's log x, and e raised to the power 2 log x, right? So the value of m is 2. Now this 2 will go over here and become the power of x, which will cancel the exponential term. So you get the final equation to be equal to y is equals to c1 plus c2 log x multiplied by x squared. Right, so I got the value of y. Now I have been given the initial condition y of 1 and y dash of 1. So I need to find out y dash of 1 as well. So if I differentiate this equation with respect to x once, before that let's multiply the x inside, so it will be easier. So you'll get c1 x square plus c2 x square log of x. Now this is the equation. This is my first equation. The second equation I'll obtain by differentiating the above equation. So I'll get 2c1x plus, first of all I'll differentiate this one keeping log x constant. So I'll get 2c2x log x. Next I'll differentiate log x keeping x square constant. So I'll get c2x, because the differentiation of log x will be 1 by x, and the x will be cancelled with 1 of the power of x over here. This becomes my second equation. Now let's try to substitute the values over here. So I get y of 1 is 0. So in the equation 1, I'll substitute the value of x equal to 1 and the y becomes 0. So 0 equals to c1 x is 1, so it will become 1 square plus c2 1 square log of 1, that is 0. So this c2 term will get cancelled out. I'll be left with c1 and the value of c1 will become 0. Now y dash of 1 is 3. This I'll substitute in equation 2. So I'll get 3 is equals to 2c1 x is 1 plus 2c2, the value of x is again 1, and log of 1, which is 0, the second term will cancel out, and the third term is c2 times the value of x is 1. I'll get this part, and the middle term will go off, so I won't have anything to do with this. I'll be left with 2c1 plus c2. Now the value of c1 is also 0, right? So this will go, so I'll get the value of c2 directly, that is 3. So I'll substitute these values in the equation of y. So I get the final equation turned out to be y is equals to, see, c1 is 0 and c2 I'll get is 3. So it will become 6x log of x plus 3x. Oops, I made a mistake. I have to substitute this over here. So the c1 term will go off. I will be left with c2 term. So it will become 3x square log x. So this is the final answer that I obtained over here, which is the solution of the given problem. Now let's try to solve the next question and see what the next question is. Now this is a pretty simple question. There is no initial condition, so I need to substitute the values over here. I'll substitute x square d square y by dx square. As you can see, the power of x and the order of differential equation is same. So this is a Cauchy's homogeneous linear equation, and I'm going to make certain substitutions over here. dy by dx, it will become d of y. Let's substitute the values. So I'll be left with d minus 1 of y plus d of y plus y is equals to 0. If I open up the brackets, I'll get d square minus d plus d plus 1 of y equals to 0. This turns out to be d square plus 1 of y is equals to 0, because the middle two terms will get cancelled out. Now, if I find out the auxiliary equation over here, the auxiliary equation will be the m square plus 1 equals to 0, or the value of m to be equal to under root of minus 1, plus or minus, which will become plus or minus I. Now, when we have the root in terms of I, the equation that we get is in terms of the trigonometric function. So the final answer of y will be in terms of c1 cos of z plus c2 sine of z. Now we know the value of z. The z is equals to log of x. So the answer that you'll be getting is cos log x plus c2 sine log x. So this will be your final answer for this question. We'll keep it up to here for this video. Thanks for watching.